Assalamu alaikum students. So today we are here for the next lecture of the unit 6 and we are going to start 6.02 of the chapter waves, sound and vibrations. Okay, so let's start with 6.02. Okay students, basically in this unit we are going to study about the wave effects. Okay, so the wave effect basically is our first heading, the major heading, and we have to figure out and we have to actually find out that what are the wave effects and how it actually works. Okay, so basically the wave effect is a property of a wave, and the properties of wave can be studied by using a ripple tank. As you can see on your screens that I have shown you a ripple tank. Okay, and what does this ripple tank do? Basically ripple mean tiny waves. So in the ripple tank, basically the tiny waves are sent across the surface of the water, and as you can see that there are some obstacles which are put in their path to see that what effect are produced, because definitely when there is a flowing water, so the when there is a flowing water, so the water will flow definitely without any type of without any type of breakage or without any type of stoppage. Whereas if there is any obstacle, so definitely it would try to overcome that obstacle, or the water will try to change its direction. So such type of phenomena would definitely occur. So basically that wave, the ripples basically are sent across the surface of the water, and the obstacle are actually placed in their path to see that what are the effects which are actually getting produced when the water passes. Okay, so as a light source we have used a light bulb. Okay, there's a source which is also present. Okay, then in the ripple tank basically there is the presence of a motor which actually produce vibrations in the water, and there is the presence of some vibrating blocks which actually produce the ripples. Okay, and the ripples are basically the as I have told you that these are the tiny waves. Okay, as you have seen, for example, if you have ever been to the water parks, so you have seen the wave pools like that. Okay, so basically the ripple tank is just like that, that it's like a wave pool. Okay, so basically the waves are produced in the ripple tank by a motor. Okay, and then due to the obstacles, due to the presence of the obstacle, we just find out that how the water actually behaves when there are some obstacle in between. Okay, so the tiny wave or the ripple, we can say that they are just sent across the surface of the water, and the obstacle are put in their path to see that what effects are getting produced. Okay, and in as you can see that I have also shown you the screen. Basically just um, we can say that there is the presence of the screen. Okay, just below the level of the water, so that the result can be seen or it can be recorded as well. Okay, so basically this is the ripple tank which is usually studied to figure out the wave facts. Okay students, so now we are moving toward the reflection. Basically what is reflection? You have to remember that a vertical surface is put in the path of a wave, and the waves when they are reflected from the surface at the same angle as they strike it. Okay, so as we have also told you that there are actually two laws of reflection, and according to the first law of reflection, the incident ray and the reflected ray, they both are of the same angles, as we have also studied. So when the wave hit an object such as a barrier or anything like an obstacle, so they can be reflected. Okay, so when the wave reflect off a barrier, the angle of reflection r is equal to the angle of reflection incidence. We can say that incidence, which is represented by I. Okay, so that we can say that the angle of reflection would be equal to the angle of reflection. Angle of incidence would be equal to the angle of reflection. So basically, you have to remember that the angle of incidence is when it's equal to the angle of reflection. It is also termed as reflection's first law or first law of reflection. Okay, so this phenomena actually occurs in the reflection. Let's talk about refraction. Basically, for example, if a flat piece of plastic makes the water more shallow and which slows the waves down, when the waves slow, they change in direction, and this effect is called refraction. Okay, So for example, when the waves enter a different medium, I mean to say that when the waves are entered into a different medium, so their speed can change definitely. Okay. For example, every person runs according to their own stamina, according to their own strengths. For example, okay, so just like that, the water, or we can say that when the wave basically at it acts, a wave acts different in different mediums. Okay, so when the wave enters a different medium, their speed can change definitely, and the effect is this effect is called refraction, and it can have two other effects. Okay, the number one effect is that the wavelength of the wave can increase or decrease. Okay, and the other one fact is the other fact is that the wave can change the direction, as you can see. Okay, so as the deep water, as we are moving from deep to shallow water, the direction is also changing. Okay, or we can say that the wavelength of the wave can also decrease or increase. Okay, so the wavelength basically is represented by a symbol called lambda. Okay, so as you can see in the picture, I have shown you that basically the light is just moving, or we can say that the waves are moving from one medium to the another medium, and the wavelength are changing, the direction is also changing. Okay, so basically this phenomenon is termed as refraction. Okay, so the water wave actually travel from deep areas to the shallow areas, and when the water waves travel from deep areas to shallow areas, they slow down. Why they slow down, or what actually the phenomena behind that? If the waves slow down, the wave will bunch together. Okay, and it will cause the wavelength to decrease. The wave will also start to travel closer to the normal. And if the wave speed up, then they will spread out, causing the wavelength to increase, and the wave will also turn slightly away from the normal. So basically these are the two different phenomena which you have to remember, whether the water wave is traveling from deep area to shallow area, or from shallow area to deep area. The next phenomena which we are going to discuss is diffraction. When the wave passed through a narrow gap, the wave spread out, and this effect is called diffraction. Okay, so the wave basically bend around the size of an obstacle or spread out as they pass through a gap, and this effect is called diffraction. The diffraction is the only significant if the size of the gap is about the same as the wavelength. Wider gap produce less diffraction. Let's talk about the factor which affect the diffraction. Okay, so diffraction, as shown, as I told you, only generally it happens when the gap is smaller than the wavelength of the wave. As the gap gets bigger, the effect gradually gets less and pronounced until in the case that the gap is very much larger than the wavelength. The wave no longer spread out at all. So basically I have also shown you some pictures that the size of the gap compared to the wavelength affects how much the wave spread out. Now diffraction can also occur when the wave passes through an edge. When a wave goes past the edge of a barrier, the wave can be curved around the edge, as you can see on your screens. Now let's talk about the last heading of 6.02, which is the wave evidence. Now the sound, light, radio signal basically all undergo reflection, refraction and diffraction. This suggests that they travel as waves. For example, light reflects from the mirror and sound reflects from hard surfaces. Then light bends when it passes from the air into the glass or water. The sound bends around obstacles, okay, such as walls or building, which is why you can hear around corners. Then the next point is that the light actually spreads when it passes through tiny holes or slits. This suggests that the light wave must have shorter wavelengths than the sound. Then the last point is that the radio signal, basically some radio signal can bend around a very large obstacles such as hills. This suggests that radio waves must have long wavelengths. Now there is an exam tip for you all. When drawing waves being reflected, take care to make sure that the angle of the incidence is equal to the angle of reflection. Keep the wavelength of the wave the same. Similarly, when the wave are diffracted, the wavelength remain constant. Refraction is one of the wave fact where the wavelength changes. And remember that the refraction is the name given to the change in the speed of a wave. Okay, when it passes from one medium to another, and the change in direction is the consequence of this. Okay, so there are some practice questions which are given on page number 127 in the fundamental physics books. Just go throughout, and these are very easy questions. Just go through them after going to the lecture. One thing I would like to remind you all that when you have completely watched this lecture, all the PPTs, all this video, then when you are just done with this lecture, so just go and read the 6.02 from your book of the fundamental physics, and then try to solve the question which I have given you. So it would become it would actually create much more clearness in the mind related to the topic of the waves and the wave effects. Thank you so very much. If you have any queries, so you can send us email, and we will get back to you ASAP.